Hi, everybody. This is your first video for Unit 3. This one is in Section 1, so um, this first section is may seem like it goes all over the place, but it'll get tied together a lot in the second section where I go into more detail on the actual normal distribution. So this video is on percentiles and cumulative relative frequency. So we're going to try to take some of the things that we did last unit and connect them to these new ideas like stem plots and box plots and things like that. All right, so let's go ahead and jump into it. Okay, so a percentile. I don't know if you all have ever been to um, like a doctor's office before, and if you've been told, for example, like you're in the 23rd percentile for weight, or you are in the 80th percentile for height or something like that. Okay. So a percentile is essentially a value, it's a percentage with P, whatever the number is, percent of observations in a data set less than that value. Okay, so if you are in the 80th percentile for height, then that means you are taller than 80% of the people in that data set. Okay, so in this example that I have for you right here, it's both on the left side and on the right side of your screen. Okay, in this example, let me turn my pen on. Okay, there's 20 test scores in this stem and leaf plot. They range from 50 all the way up to 94. Okay, we have one student that scored 76%, which is this student right here. Okay, so because there are 6 scores less than that, okay, 1, 2, 3, 4, 5, 6. Okay, there's 6 scores less than that student score, okay, which means that they are in the percentile, they are in the 30th percentile, right? So the way that you calculate a percentile is you literally just count um, how many observations are below that data point, which in this case is 6, and then you have to divide that by however many total observations you have, which in this case is 20, and convert that to a percentage, which is 0.3 or 30%. Okay, so that means this person is in the 30th percentile. Okay. So literally, so if you're asked to interpret a percentile, it is quite literally the percent of observations that are less than a particular value, right? So meaning that you have a higher score or are taller than or way more or whatever it is, right? Whatever the context of the data is, than that percent of the population. Okay, so I'm going to do one of these examples here with this stem plot with the Minnesota Twins, with this baseball data. Let me clear my screen off here. Okay, so I'm going to do one of these examples on the right-hand side, and then I'm going to encourage you to pause the video and try it out, try the other two out on your own. Okay, so I have this stem plot here that says I have, there's 30 baseball teams, okay, and I'm trying to find the percentile for these teams, okay? So for the Minnesota Twins, they won 66 games, so this is their data point right here. So I just have to count my percentile, and I'm abbreviating with the percentage sign and then the word tile. The percentile here is the total number of observations below, which is 3, divided by the number of observations total, which is 30. So 3 divided by 30 is 1/10. So 0.1, which is 10%. So that means the Minnesota Twins are in the 10th percentile. Okay, and if you had to interpret this in context, this percentile would mean that the Minnesota Twins won more than 10% of the other baseball, Major League Baseball teams. Okay. One thing that I want to make sure I point out to you before you try this second and this third one on your own is that it's always the data values less than that particular value. You would never include, you don't include the observation that you are isolating, the one you're trying to find the percentile for. You never include that when you're calculating a percentile. It's only the number of observations less than that value, the percentage that are less than that particular value that you're looking at. Okay, so I'm going to take a second and pause the video. I want you to try 2 and 3 for calculating percentiles on your own. Then check back with me and see how you did. All right, y'all, so I'm gonna make this a little smaller on the left here so that you can see the work a little bit easier on the right-hand side of your screen. Okay, so check your answers against mine. So for 2, the Washington Nationals were 98 games, which is the very last data point here. So there's 29 teams that are below them. Right, so 29 over 30 total, which is 96.7%. And then I did not ask you to write an interpretation here, but I wrote the interpretation out for you just in case you wanted to see it. Okay, so if I was to interpret this percentile, I would say the Washington Nationals won more games than 96.7 of MLB teams in 2012. Okay, and this is something important to bring up. Okay, why are they not in the 100th percentile? Like, why is that not the case, right? And the reason is because percentile is always the values that are less than that data value, not that are less than or equal to that value. So they can't be in the 100th percentile because that would mean that they won more games than themselves, which is not possible. Okay. All right, then 3 was a little bit tricky. You might have gotten a slightly different answer than me, depending on how you did this. But this is asking for the percentile of the Texas Rangers and the Baltimore Orioles. I'm probably pronouncing that wrong, who both won 93 games. So as you can see, when I circled these, that I circled both, right, because they scored the same amount. So say if I was just finding this for the Rangers, right? A percentile is always the values that are less than, in this case, the score that are the number of games that they won. So if 2 teams win the same number of games, then they're going to have the same percentile, right? Because they both won 93 games, right? So there's not one that's less than the other. Okay, so for the observations below, I would count all of the observations below the lowest 93, or the first one listed. So there's 22 of those observations, okay, over or out of 30 observations total, which is 73.3%. So your interpretation, if you were to interpret this, would be that the Texas Rangers and the Baltimore Orioles won more games than 73.3% of MLB teams. And then I forgot to write in 2012. Okay, so give me 1 second. I have to switch slides and clear my screen, and then we're going to talk about cumulative relative frequency. All right, folks, so let's talk about cumulative relative frequency, which sounds kind of frightening, but actually is not super complicated, okay? So you've heard me talk about this term relative frequency before, okay, which is basically just a percentage. Okay, right? So it would be the total number in a category, or a bin, or maybe like a stem on a stem and leaf plot divided by the total number of observations in the data set. Okay, so that is relative frequency, right? Relative meaning like percentage, essentially, right? And frequency is like count. Okay. Cumulative relative frequency is exactly what it sounds like. Cumulative means to add up over time. Okay. So it's the number in a particular category plus all data points below that value divided by the total. So it's essentially a percentile. Right? But it's something that we can graph. Okay. Right. So what's cool about cumulative relative frequency is that if you can graph these points, it can tell you a lot about the distributions that you're dealing with. Um, and it can also be used to determine IQR and skew. Okay. And I'm going to show you what I mean by that in a second. When I go to the next part of this, because it actually has a cumulative relative frequency graph on it. Okay. So on a cumulative relative frequency graph, the first point will be at 0% on the y-axis, right? Because there's no data below that point, right? It'll be at basically 0%. Okay, and then the last point, right, will be at 100% on the y-axis. Okay, because all of the data is either that point or a point below it. Okay, and that's where cumulative relative frequency differs a little bit from percentile. Okay, because when you're just calculating percentile outright from, say, like a stem plot, like we did in the last one, um, because that actual data point is included in cumulative relative frequency, and it's not included when you're calculating a percentile, right? Normally those percentages are so like they're not very different when you calculate percentages that way, like with cumulative relative frequency versus percentile, that sometimes the terms in statistics are used interchangeably. Okay. So then there's one other thing here that's really interesting about cumulative relative frequency graphs is that you can help us figure out where quartiles and IQR are, and it also helps us figure out skew, right? Because if you remember from when we talked about quartiles, right, quartile 1 is where you have 25% of your data. I kind of sketch out a box plot here. Okay, quartile 1 is right here, where you have 25% of your data below that point, right? So quartile 1 is like the 25th percentile. Okay, quartile 3, which is up here, right, has 75% of the data below that value. Okay, so quartile 3 is at your 75th percentile. Okay, so that's how it can help us determine quartiles, median, IQR, right? It can also help us determine skew. Okay, so and like I said, I'll kind of show this to you in when you can see it on the next slide. But if you have a cumulative relative frequency graph that is very steep at first and then levels off, so something that looks, I'm gonna circle it here in yellow and kind of draw it underneath. So something that looks almost like this, for example, right? You have all of these points connected. Right, I didn't draw that very well, right? But these points are all like connected. You have a point here, here. These really should be connected, and I didn't draw this very well. Okay, right? So remember what this means, since this top point up here is 100% and the bottom point is 0%, if you have a lot of data, right? Because your percentiles are over on the y-axis, right? If it's really steep, then that means you have a large percentage of your data in a very small grouping of x values. So if you were to convert this to like a histogram, right, you would have a very large amount of your data points in a very small x space, right? And then a smaller percentage of your data in like a longer, right, x. So this is skewed to the right, okay? And then if you have something like this that's very flat at first, right? So maybe you have, so here's a data point, here's a data point, here's one, and then you have something that looks like this, right? Where this is your cumulative relative frequency graph. Okay, because remember that it's the percentile that's on the y-axis, right? So what this means is that you have a small percentage of your data cover a very large number of your x values, and then you have a lot of your data on the right that is encompassed in a very short, in a very small range of x values. So if you were to convert this to a histogram, right, we have a very small percentage of our data, like our data points, kind of over here that's spread out, and then you have a very large amount of your data kind of there closer to the end, right? So that is skewed left, right? And this one was skewed right. Okay, the way I kind of like to remember this is the cumulative relative frequency graphs that are skewed to the right almost look like lowercase r's. Like you can kind of see it here. It looks like this, right? Which kind of looks like a lowercase r if you add the little stem on there, right? So that's the way, at least for me, that I kind of like to think about it, and I like to remember it. Okay, so give me a second to clear the screen off, and then I'm going to talk you through an example, and we'll look at this in a little bit more detail. All right, folks, so here is a much better drawing of a cumulative relative frequency graph, as well as the table where the information came from. So this data is on median household income in thousands. So it's starting in your X at the lowest value was 35,000, highest value was 70,000. Okay, so here in the table, they showed you the frequency, right, which is the count in that particular in that particular bin. So there was only one data entry in this first bin, 10 in the second, 14 in the third, etc., etc. Okay, and then the relative frequency is just the number in that bin divided by the total, which is 51. Okay, the cumulative frequency, right, is when you take the value in that bin plus everything below it, right? So they did, to get the 11, right, added 10 and 1. To get 25, trying to change my colors here. To get 25, added the 14, the 10, and the 1, etc., etc., until at the very end, you have all of your data points for the cumulative frequency in the last bin. Okay, so then the cumulative relative frequency is the cumulative frequency divided by the total number of observations. So notice how the cumulative frequency keeps increasing, right? Because every single time you add more data, okay? And then all of that is taken and put here on this cumulative relative frequency graph, okay? And what you can see from this is each of these, like the cumulative relative frequency points that are just connected um, on this graph, right? Starts at 0% all the way up to 100%. Okay, so I want to show you a couple of cool things that you can do with these graphs, because remember that the y-axis here is essentially your percentile. Okay, so say I wanted to figure out where the median was. And so I'm going to do that in purple, median. Right? Right, so say I wanted to figure out where the median was. Well, I know the median is at the 50th percentile, right? It's at 50%, it's got to be at the middle, right? So 50th percentile is right here. Okay, so I can kind of draw a line over, right? And then a line down to figure out what X value gives you, so what median household income gives you the is like at the median, which is the at the 50th percentile, which here it looks like it's about 50, right? Say I wanted to find what my, say I wanted to find what value was at the, or say I wanted to find the percentile of people who earn at least $65,000 in their household, right? So from there, I know the X value, so I'm going to shoot all the way up, right? My line's a little curved, but drawing with a mouse, doing the best I can here. Okay, so that where it hits the cumulative relative frequency graph, I'm then going to draw a line over. So I can see that that percentile is probably around 95%. Right? Because that's where it landed for the cumulative relative frequency graph. Okay, so if you were asked to interpret a cumulative relative frequency or interpret a coordinate point on a cumulative relative frequency graph, you can see that interpretation on the left side of your screen here, which is the point 50.49, which is this point here in purple that I had to estimate a little bit, did the best I could with the drawing that I had. Okay, so what that means is that 49% of states had a median household income less than 50,000. Okay, because remember, this is the percentile, right? The Y is like the percentile. Okay, it's the cumulative relative frequency, and the X value is like the observation, right? It's the individual data point or observation. Okay, so you can see on the right side of your screen that you have this same cumulative relative frequency graph. I want you to see if you can answer these 4 questions. See if you can answer. See if you can answer these 4 questions related to this graph. Okay, so keeping in mind that each of these data points that you see are individual states, right? So some states have a higher median household income than others, right? So like this 50 median household income would correspond to a particular state that has a median household income of $50,000, right? And the percentile or cumulative relative frequency associated with it, right, says that that percentage, right, of states have a smaller median household income than that state. Okay, one of the great things about using these cumulative relative frequency graphs is even if you don't have all of the data for every individual state, if you have a couple, right, like we don't have the individual median household income for every single state using this data that they gave us. We don't have that, right? But we can estimate what their percentiles are with just a couple of data points, which is kind of cool. Okay, so try those 4 questions, which the first one I kind of showed you how to answer. So give those a try, and I will see you back here in just a second. You can check your answers against mine. All right, folks, so go ahead and check your answers against mine. I wrote all of my answers here on the right side of your screen. So one says, at what percentile is California? Whose median income is $57,445. So I'm going to zoom in a little bit so you can see what I did here. So 57,445 is approximately here, right? So I drew a line straight up to where I hit the cumulative relative frequency graph, and then a line straight over to read what the cumulative relative frequency was, i.e. what the percentile was. Okay, and so I found, just because of my own drawing and possible error, you can round and say it was approximately the 80th percentile. Okay, for the second one, they said Nevada's mean income was around 52,000. Okay, so here's my line that I've drawn at about 52,000, and then right straight up where it hit the cumulative relative frequency graph, and then straight over. So that's, again, I think part of the issue is my lines were not perfectly aligned here. So I rounded and said that's approximately at the 60th percentile. So Nevada is at the 60th percentile, but the question asked what percent of states had a higher household income than Nevada. Okay, percentile is the percentage that had a lower household income than that data point. So if 60% of states had a lower household income than Nevada, then that means 40% of states had a higher income than Nevada. Okay. The next question said to estimate the first quartile, third quartile, and IQR. Okay. So for this one, I didn't start down here on the x-axis with the median household incomes because I don't know what those are, but I do know what the percentiles are. Okay. Quartile 1 is the 25th percentile. Quarter 3 is the 75th percentile. So if you go back up to the graph, I wrote those drew those lines in black and identified them in black ink, okay? So 25th percentile is approximately right here on the y-axis. So I drew a line over first to where I hit the CRF graph, cumulative relative frequency graph, and then went down to estimate what the median household income was, which is, I would say, about 45,000. Okay, and then you do the same thing for quartile 3. But quartile 3 is at 75% on the cumulative relative frequency graph. Okay, so I started at 75%, went over until I hit the CRF graph, and then went down and got about, I said 54,000 there, I believe. Okay, so that means my IQR is 54,000 minus 45,000, which is 9,000. Okay, so that's my IQR. Right? And then it asked me to interpret those values in context. So the quartile 1 interpretation is essentially a percentile interpretation. That 25% of states have incomes lower than 45,000. And I abbreviated a little bit because I was running out of space, but really I should have said 25% of states have median household incomes, right, to be more specific and to put those more in context. Okay, quartile 3 is a very similar interpretation, and then your interpretation of IQR is you're taking essentially the definition of IQR and putting it in the context of this problem. So the definition of IQR is that it's the middle 50% of the data. So the interpretation of the IQR is that the middle 50% of states have a range, because that's what IQR is, a range of approximately $9,000 in median household income. Okay, all right, then the very last one asked, is this data symmetric or skewed? And this data is essentially symmetric. Okay, if you go back up to the cumulative relative frequency graph, this almost looks like a straight line, right? Almost. And I could draw one on here, right? This is almost a straight line, like basically, right, with a little bit of curvature. Okay, so cumulative relative frequency graphs that are really skewed, or that represent skewed data, will have a much more extreme curve in them. Okay, so I said that this data is symmetric because the cumulative relative frequency graph is essentially a straight line. Okay, and that skewed data would have a much more extreme curve. So, for example, right, you may have a graph that looks more like this, right? That graph is definitely skewed, right? That CRF graph is definitely skewed, or something that looks like that, right? That is definitely more skewed. Okay, so essentially, like things that look like logarithmic curves or that look like exponential curves, those are going to be skewed. Okay, and remember, these, the ones that are steep at first and then kind of flatten out, are skewed to the right. Okay, you can almost think of this this flat part as like the tail, right? And ones that looks like this would be skewed to the left. All right, y'all. So that is it for percentiles and cumulative relative frequency. I will see you in the next video to talk about z-scores. See y'all later. Bye.